Hello everyone. Today let us learn what is organic chemistry or what are organic compounds. This is a very important chapter in Standard 10 icse chemistry. So let us begin. Organic compounds are the compounds of carbon. Organic compounds are the compounds of carbon. Does this mean that even carbon monoxide, carbon dioxide, or all those carbonates, calcium carbonate, zinc carbonate, all of them, are they all organic? No, they are not organic. So, what kind of carbon compounds are organic? Only those compounds in which carbon is connected to certain other elements, atoms of certain other elements like hydrogen, oxygen, halogen, and even sulfur, nitrogen, etc. So very few elements are taking part in the formation of organic compounds. Even then, there are millions of organic compounds. Even though very few elements are taking part in the formation of organic compounds, we have millions of organic compounds. So why is it so? That is because of the uniqueness of carbon. So today we are going to find out why is carbon unique. Okay, carbon is unique. That is why we have a lot of organic compounds. Now, there are four properties that make carbon unique. In that, first one is the tetravalency of carbon. Tetravalency. As the word tetravalency indicates, each carbon has to form 4 bonds. So in an organic compound, there won't be less than 4 bonds on a carbon. There can't be more than 4 bonds also. Each and every carbon has to form 4 bonds. So our first point is carbon connects with other elements. First point, okay, other elements by means of covalent bond. So the tetravalency is actually covalency of carbon by means of covalent bonds, and each carbon forms 4 covalent bonds. That is the first point which makes carbon unique. The tetracovalency of carbon. Tetravalency or tetracovalency, which means in the outer shell of carbon, there are 4 electrons available for covalent bond formation. These electrons undergo mutual sharing of electron with atoms of other elements. Moving on, the second property which makes carbon unique is catenation. Okay, now I cannot say that carbon is the only element in the periodic table which shows catenation, but we must definitely say that carbon is the only element which shows catenation to a great extent, meaning large number of carbon atoms, hundreds of carbon atoms can link together. They can connect with each other by covalent bonds. So this self-linking, this is the key word, the self-linking property of carbon. The self-linking property of carbon Okay, and this property, so I'm writing which helps carbon, the self-linking property helps carbon to form, okay, long, straight chains, or it can be branched chains. It can be straight or it can be branched chains, or it can even be cyclic structures, meaning closed chain structure. So this particular property of carbon, which makes one carbon to connect with the second, second to the third, and so on, a result of which will be long, straight or branched chains, or even cyclic structure. So we mean that one carbon can be connected with the second and to the third, so on. This is a straight chain. You can even have branched chains like this, or you can even have closed structured carbons. All this is called, or this particular property of carbon is called catenation. The third property that makes carbon unique is its ability to form multiple bonds. The ability of carbon to form multiple bonds. Here, what I mean is, suppose you have just two carbons. Even then, you can have three compounds possible. Just with two carbon atoms, you can get three different structures possible. The first one, connect both the carbons by means of a single bond. Connect the two carbons by means of a double bond, or connect them by means of a triple bond. So this triple bond is maximum. All right. Even when you have just two carbon atoms in a compound, you can still get three possible structures. The two carbons can be connected by single, double, or triple bonds. Different compounds will be the result. Now, this is called formation of multiple bonds. This in detail we will be studying. Alkane, alkene, alkyne. In detail, we must study. Now, the fourth property, the last property that we need to study that makes carbon unique is isomerism. Organic compounds or the compounds of carbon can show isomerism. So what is isomerism, or what are isomers? Compounds having the same molecular formula. Compounds having the same molecular formula, but different structure. Compounds having the same molecular formula, but different structure are called isomers. And the phenomena in which you see compounds with same molecular formula but different structure, the phenomena is called isomerism, or this property is called isomerism. These are the four properties which make carbon unique. That is tetravalency. Each carbon has to form four bonds. Second is catenation. Carbon can be connected to each other. Yeah, large number of carbon atoms can be connected to each other. Third one, even when you have just two carbons, or even have more number of carbon, I meant that with two carbons, you get three structures possible. Yeah, you can connect carbons by single, double, or by triple bond. And the last one is isomerism. As per our syllabus, we need to learn isomerism also in detail. So one example let me take to make you understand what isomerism is. Suppose you have a hydrocarbon compound which contains just atoms of carbon and hydrogen. So let me write the structure. CH3, CH2, CH2, CH3. Whatever be the name of this compound, all right? What is its molecular formula? C. 1, 2, 3, 4 carbons are there. H. 3 plus 3, 6, 6 plus 4, 10. So this is C4H10. The same structure can also be written like this: CH3, CH, and a CH3 like this here as a branch, and one more here. Now, count the number of carbon. 4 carbons are there, and hydrogen, 3 into 3 plus 1. 10 hydrogen. So both of them have the same molecular formula, and the structure is different. One is a straight chain compound and the other one is a branched compound. Okay, so these are the 4 properties that make carbon unique. I hope you understood why is carbon unique. Stay tuned for more videos. Thank you.